Hey Calculus, this is Mr. Szybisty, and today we're going to talk about chapter 2.1, which is about this thing called a derivative. Now, in your book, you can read a great deal about where the derivative comes from and what it talks about, but for the most part, what we're going to use is the derivative means slope. So if we have some graph of something like this, at any point on that graph, we talked about there existing a tangent line. And what the derivative will tell us is the slope of that tangent line at a particular point. This is one of the big things we're going to use, and as we go through chapter 2, we'll see how the derivative ties into everything that we've learned about so far. But for right now, I want to talk to you about this thing called the power rule. Now, to find a derivative of something like 4x to the third power, what we're going to do is start with the exponent up top, and it's going to come down, and we're going to multiply that 4 out front. So 3 times 4 is 12. And then I write the x. And then with the exponent, I'm going to take it down 1. I'm going to subtract 1, 12x squared. So the derivative of 4x cubed is 12x squared. And there's a couple different ways that we write that. We write derivative. The first way that I'll show you right now is by writing d dx. And what that notation means is take the derivative of this. Let's get into some more polynomials where we can practice this power rule. All right, we've got our polynomial, and so we bring down the exponent and multiply it. So this would be 15x, and then subtract 1 from the exponent, squared, minus the 2 comes down, multiplies the multiplies the 3 and gives you 6. X, 2 minus 1 would be x to the first power. 2x, let's look at this over here. That's really 2x raised to the first power. So when I bring down the 1, this would be 2 times x raised to the, subtract the exponent by 1, 2x to the 0 power. X to the 0 power is really 1, so that's just 2. So I have plus 2, and then finally I have the minus 1. And when I look at the minus 1, that's really something like minus 1 x to the 0 power. So when the 0 comes down and multiplies the negative 1, that results in a 0. So there's nothing else I could say. There's my derivative, 15x squared minus 6x plus 2. When we use function notation like this, the way that we denote a derivative is with f prime. That's how we call it a derivative. So the derivative f prime of x is 15x squared minus 6x plus 2. Let's go on to the next example. Bring down the 2, so this is 20x plus, bring down the 1, 7, and then the constant, the derivative is just 0, so here's g prime of x, 20x plus 7. To find h prime of x, we start with the first term, we bring down the 1, 2 times 1 is 2, and then the constant, the derivative of a constant is 0, so we're left with h prime of x equals 2. Now this is a very interesting example, mostly because our original function, 2x plus 1, is a line. And you can always tell the slope of a line when it's in this slope-intercept form by looking at this coefficient. Notice it has a slope of 2. But then take a look at the derivative. Remember before that we said that the derivative means slope. It's the slope of a function. What this is saying is that our function h of x at every point has a slope of 2. And you noticed right here that that is a true statement. So this is an interesting part of calculus where everything that we've learned before in algebra can now be shown and proven using some calculus techniques. Now let's get on to the next example. Now we've got this function. So to find its derivatives, to find j prime, this would be 3x squared minus 4x minus 3. Remember, we're bringing down the exponent and then subtracting the exponent by 1. What these notations mean is take the derivative again. J double prime of x means 6x minus 4. J double prime is just the derivative of j prime. J triple prime is the derivative of the second derivative, j double prime here, it's the next derivative, and this would just be 6, and the derivative of a constant is nothing. And then finally, j to the fourth, that's the fourth derivative of x. The derivative of 6, the derivative of a constant, is just 0. And if you continued on, the fifth derivative, the derivative of 0 is 0, and then the sixth derivative is the derivative of the fifth. Derivative of 0 is 0, and so on and so on. And it continues on forever. So this is the way that we write first derivative, second derivative, third derivative, fourth derivative, and so on. Let's see the next example. Now let's talk about some trig functions and the derivatives that go with that. In class, I could show you how each of these comes up, but for right now, the most important part is remembering them. The derivative of sine x is cosine, and the derivative of cosine is negative sine. The derivative of negative sine. An interesting thing that I want to show you right now about if there's a constant like this right here, this negative 1, what we are allowed to do when there's a constant and we're taking the derivative is we can pull it to the outside and apply it later, multiply it later. So this is negative derivative of sine. And we already learned before that the derivative of sine was cosine. So this is equal to negative cosine. And in the same way, the derivative of negative cosine is negative derivative of cosine, which is negative. The derivative of cosine is negative sine. So this is just sine. One of the interesting things that you get from this is you get this progression. Sine, cosine, negative sine, negative cosine. The derivative of the sine is cosine, the derivative of cosine is negative sine, the derivative of this is this, and then it repeats back up. The derivative of negative cosine is positive sine. So if you can remember these four, you're good, sort of this order as they go down. As you go down, you're taking derivatives one after another. So that's how you can remember your trig derivatives for sine and cosine. Now it's time for a you try. Pause the video and take the derivative of 5 cosine x. Remember, with a constant that you're taking the derivative of, you can pull it to the outside. The correct answer is negative 5 sine x. If you've got it, congratulations. If not, we'll talk about it next time in class. Let's move on. There are two main transcendental functions that we study in calculus. The first one is e to the x, and the second one is natural log of x. The derivatives for them both we'll take a look at right now. The derivative of e to the x is e to the x. And the derivative of natural log is 1 over x. These are two facts you just got to know, and if you've got them, you're going to be successful in calculus. Here we're asked to write the equation for a tangent line, which means what we're actually going to do based on a given graph, and at a particular point, we'll actually find the equation of the line that's tangent. So I've got my function here, it's this cubic, and I know at x equals 2 is the point I want to work at. Whenever I want to write the equation of a line, I'm going to need two pieces of information. You need to know slope of the line at that point, and you also need to know the coordinates, the actual point. The slope is what I'm going to use the derivative for. Remember, the derivative means slope. So the derivative of this function is f prime of x is 6x squared minus 6x plus 2. And if we're looking for what the slope is at x equals 2, I'm going to plug in the 2 into the derivative. So this would be 6 times 4 minus 6 times 4 plus 2, and that gives me 2. So there's my slope. My slope is 2. In order to find my point, I'm going to use the original function again, because that'll tell me my height or my y value at this particular x value. So f of 2 would be 2 times 8 minus 3 times 4 plus 2 times 2 plus 1 is 9. So now I've got my point. My point is 2 comma 9. The way that we write the equation for a line when you've got the slope and a point is called point-slope form. Y minus y naught equals m x minus x naught. The m is your slope, and the x sub 0 and y sub 0 is your point. Substituting in, I get y minus 9 equals 2x minus 2. The only other thing that you've got to do is just add the 9 over to the other side to make it y equals. Y equals 9 plus 2, x minus 2, and you're done. There's the equation of the line for your tangent line. So here, same thing, equation of a line, so I'm going to need slope and point. I'll start with slope. F prime is going to be 2 times 1 over x, so it's just 2 over x. And at x equals 5, the derivative at 5 is 2/5. So I've got the slope. Now it's time for the point. F of 5 will give me the y value. This is 2 natural log of 5. And there's nothing I can really do to simplify this because I don't know the natural log of 5. So I know that the point is 5 comma 2 log 5. Now it's time to write the equation of the line. So we do y minus y naught equals the slope x minus x naught. And we just add the y value over, so we end up with y equals 2 log 5 plus 2/5 x minus 5. And there is my equation for the tangent line. Now it's time for a u-try. Write the equation of the line just like we did in the past two examples for this function, this quadratic right here, and your x value is x equals 3. Pause video, give it a try. The answer we get is y equals 16 plus 8 times x minus 3. You've got your point, and you've got the slope. If you got it, congratulations. If not, make sure you try to figure out where you went wrong, try it again, and come to class with questions. The last thing we're going to talk about is taking the derivative of a square root. The rule is 1 over 2 times the square root of x. But every now and then, we're asked to take the derivative of something a little more complicated. What if we were asked to take the derivative of something like the square root of 3x cubed minus 2x squared plus 1? Well, it's not going to be as simple as just this. Here's the rule. When you are taking the derivative of a square root, but there's a function inside that square root, what you do is you do the usual 1 over 2 square root of, keep that function inside, and then multiply it by the derivative of whatever was inside the square root. Let's see how that works in a real example. So here's that one we were talking about. So I know that this is going to be 1 over 2 square root of 3x cubed minus 2x squared plus 1 times the derivative of what's on the inside. The derivative of the inside is 9x squared minus 4x. And so now what I will typically do is I will multiply these fractions together and end up with a combined 9x squared minus 4x over 2 square root of 3x cubed minus 2x squared plus 1. And that is my derivative for this function, which was a square root, but it had something inside. So I had to remember about the derivative of the inside going here and multiplying on the outside. We've got our final u-try it today. Now we've got another square root, and it's got a different function in there. Can you find the derivative? Pause the video and let's see. The correct answer is negative 5 sine x over 2 square root 5 cosine x. Hopefully you got the right answer and the right derivative. If not, make sure you write down a couple questions. I'll see you guys next class period so we can explore the derivatives some more.